Good day, everyone. So what do we have? We have a letter. We have this letter that is coming from another city, that is Plantry. So this is a letter from another technician of another city. So we have to reply this letter. Can you reply the letter? I think we can. So let's open the envelope. Let's open this envelope and try to help this customer. Yeah, the customer is a big fan on YouTube. He was saying, I was watching your videos and I'm 100% sure you can help me on my motherboard. This is a cell phone technician, but he can't fix a laptop motherboard. That is the main reason why I always emphasize people to learn electronics rather than learning fixing phones or TVs. Because if you know the basics, you can fix anything. You can fix anything. It's sealed. The envelope is sealed. I'm eager to know what kind of letter do we have inside. Anyway, we'll put it on the proper package when we return the motherboard. It's not supposed to come inside an envelope. Because if anything happens, this can damage the components. We have a motherboard here. This is an old motherboard. I believe this has to be like an HP motherboard. Here we have a charging port. Is this charging port okay? The charging port doesn't look good from inside, but that can be a secondary problem. I don't think the customer failed to notice that this charging port is broken. So where's the adapter for this one? We need the right adapter for the HP, this one. Okay. What? Let's go to 19 volts. 19 volts. 3.4 amps. Plug in the power. It's taking 2.7 and it's taking max current. Yeah, it's shorted. The motherboard has got short to ground. So now we don't know whether the short is coming from the charging port or from the motherboard, because this charging port doesn't look good. If you pay close attention, let's go under microscope. Maybe you can see what I'm seeing. That's the charging port. Which is broken. So what I want to do, I want to inspect this motherboard. That's what we can do. We have some components here. We're just doing a random inspection. Maybe we can spot something obvious. We want to go on any power supply, like this one. Those MOSFETs doesn't look okay. multimeter. Let's go on. Someone said I should not go on diode mode, I should go on resistance mode. So let's go on the resistance. I don't know why people they try to teach others how to do things. Me, I'm concerned about the end result. Here on this capacitor, 2.7 ohms. So 2.7 ohms, this is a 19 volts ceramic capacitor, which is connected. One side is connected on the, you can see this side is going to this MOSFET, is connected on the, this looks like the high side MOSFET and the lower side MOSFET. And here we have the output electrolyte capacitor. This is a switching power supply. So if we have 2.7 ohms on the 2.75 ohms on this ceramic capacitor, which is meant to work with 19 volts, it means the main 19 volts power line is shorted. But what I would do, let's disconnect the charging port here. Let's go back on that ceramic capacitor and check again. Here 2.69, we still have a problem. Let's check the input section. You know those ceramic capacitors, input MOSFET here, ground 2.7. So we have 2.67 ohms checking to ground. You can see my black probe is connected on the ground and this one on the current resistor. And it's reading 2.8, 2.7 ohms. So we have a short. I'm working on the resistance mode. I just want to prove to the subscriber that working on resistance or on diode, it doesn't matter. What matters is the end result. Huh? So let's check those MOSFETs. We're not using diode mode. We're on the resistance mode. Maybe we can fix this motherboard. Infinite resistance here. Seven kilo ohms on this one. 0 ohms. This is a 0 ohms MOSFET. So this MOSFET is open. We have this MOSFET which is open. And this is a channel P MOSFET. 3 pins together, we have the gate to ground. Uh, 111 kilo ohms, but source to drain is open. We have like 0 ohms. So the first MOSFET is shorted. So let's go ahead. We found the first problem. The first MOSFET is open. Source to drain, we must not have something like 0 ohms. It means that something is wrong with this MOSFET. Let's inspect other things. Let's inspect other things. What is here? What is here? I think here is the problem. Why those ceramic capacitors? This one is blown up and this one is blown up. So I think we just see the problem. Let's replace those capacitors. This is an obvious fault. I'm looking for replacements. Let's take down those ceramic capacitors. So these two ceramic capacitors, we don't know which one is shorted, but based on what I'm seeing, I'll replace both of these capacitors. I think we can clean. Let's check again with the multimeter. Exactly on those capacitors. We are still using ohms range. It's now 480 ohms from 2.7 ohms. So the short is gone. So let's go back on the input MOSFETs here. Let's check here on that MOSFET which I was suspecting to be the problem. This one, the first one, drain to source and 0.21 ohms, almost 0 ohms. Let's go to on the beeping mode. I'm sure it's beeping. Yeah, it is beeping. So we need to replace the MOSFET with another P-channel MOSFET. Replacement. I'm sure if we don't replace the motherboard, the MOSFET, the motherboard might work, but it won't charge. So it's wise to replace the MOSFET just to avoid problems. MOSFET. MOSFET is out. We need to clean. Maybe let's replace this MOSFET. Now, all what we need to do is to clean. Let's test source to drain. And the source to drain is not beeping. On the MOSFET, exactly if we check on the MOSFET, it's beeping. So this MOSFET is shorted from drain to source. You see? Zero ohms. So I'm sure this job is done. So the MOSFET was shorted in those ceramic capacitors. I'm sure I must have a working motherboard now. What do you think about this? Do you think we now have a working motherboard? So here, working on the ohms range and working on the diode mode, all must give you one answer if you know what you are doing. So it's not about why you are using resistance mode, why you are using diode range. It's all about the result. To me, what matters is the end result. If I can manage to fix it on the ohms range, that will be fine. If I can manage to fix a device using the beeping mode, using whatever range that you are using either you are using a oscilloscope or you are not even using a multimeter, you are checking with your oscilloscope what are the voltage signals doing. As long as that will give you the answer, just carry on. So we need to test the motherboard. We need to test the motherboard. That's the first thing, to test if the motherboard is working. Plug in the charger, and we now have a light. You see the light, and it's taking 20 milliamps, right? Standby current. What I will do, I will plug the HDMI and we try to pay attention on the big screen there. Pay attention there. I'll plug the the HDMI cable and try to power on the motherboard. You know how we are powering the motherboard. If you don't have the ribbon cable for the power on button, you are shorting pins to ground it by a tweezer. The motherboard is on. Paying attention here, and it's working. You see, CMOS what invalid, reset the motherboard, blah blah blah. The motherboard is working fine. It's working fine. The fan is spinning. If you check here, the fan is spinning at full speed, and it's taking 260. And we have display. So yeah, the job is done. The job is done. What I would say, this is a job from another city, and we try to satisfy the customer by following every step on how you can diagnose and fix a dead laptop motherboard. So if you have anything that you want to ask, if you want to leave a comment, please don't hesitate to leave a comment. And also, if you still have your friends and relatives and your colleagues who have not yet seen the channel, just share the link of the channel to your friends and relatives. And also, don't forget to subscribe and turn on the notification bell for future updates. See you on the next repair. Bye.